series of webinars organized as National Technology Day celebrations by KCST in association with APJ Abdul Kalam Technological University. We have with us Dr. K.R. Suresh Nair, who will be taking us through innovation and social entrepreneurship. About Dr. Suresh Nair. Suresh Nair is an alumnus of IIT Bombay, and he has spent his initial career at Samir R&D Lab of Ministry of Information Technology, Government of India. He then joined SFO Technologies Nest Group as Global Chief Technology Officer, heading the technology strategies. Under his leadership, many novel products in healthcare communication, industrial, aerospace, and defense domains were designed, and many are finding excellent market opportunities and acceptance globally. Dr. Suresh Nair is presently the Chief Technology Advisor to Foundation for Innovation and Social Entrepreneurship, an initiative of Tata Trust. He also founded two companies, Design Alpha and Biophoton Technologies. Dr. Suresh has more than 120 publications, 18 patents, co-authored 3 books, and more than 200 technical reports to his credit. He has been conferred with many awards, including IEEE MG Achievement Award, IEEE Outstanding Researcher Award, DST Lockheed Martin Award 2014 for the top innovation as ranked #1 in India, and many others. He is chairman of many Government of India committees, and he is also currently the chair IEEE India Council and is an active promoter of Academy Industry Association. We are fortunate to have Dr. Suresh Nair with us today. Thank you, sir, for accepting our invitation, and over to you for the talk, sir.
Thank you, Dr. Sherry. So let me try to share my screen. Is it visible now?
Yes, sir, it is visible.
Okay. So straight away get on. Yeah, thank you very much for having me. I think I know, it's a series, so less people will be coming through to attend these seminars. I will be very brief. So here the topic is innovation and social entrepreneurship, because every day we are always talking about innovation as well as entrepreneurship. Even for the graduate students and all, they start thinking on the entrepreneurship. So I thought I will try to give some ideas about how to start and what is really an innovation and things like that. Before getting on to that, I'm sure some academicians are also there, and probably the students are also there. I wanted to explain, since this is a Science and Technology Council, we have a lot of activities under science. Probably these are all under fundamental research, and the output from such programs are international publications, like publication in Nature and things like that. That is what is expected. And the output from these fundamental research, that is science, should get on to the applied research, or we call it as a technology side. So whatever output comes from the science should go to the technology. And here, the institutes, if I can tell, many of the IITs are there, then other scientific institutes are there, then DSIR, and so many labs are there. So they use these science and then do some sort of an applied research, and the expectation, of course, there are publication, but mainly it can be patents and copyrights. That is what is expected. So the output from these applied research should get on to an industry. That is what the point which I want to make. Then only whatever scientific research we do, it gets converted into applied research or technology, and then to a usable equipment or product. Otherwise, what happens is it all remains as publications and patents in our own name. So our CV can be made, better, but there is not much use or benefit directly to the society. This is, of course, teaching students also is serving the society, but I'm talking about direct contribution to the society. So this, loop has to happen. When you are converting that into a commercial product, it's not only serving the society, but you have to also make a living. So, you make some money also. So as a startup or as a company. Now, one more slide before I get into the same, my subject here. So if you look at the fundamental research, most of the funding comes from government funding. Okay, that is taxpayers' money which is being used for government funding, and also applied research in many of the areas it is government funding. Okay, so now what happens is like the industry takes over this technology and comes up with the product, and they sell the product. They make direct tax payment to the government on sales and indirect taxes. So many taxes are there. So the industries have to pay, and this money goes back to the government for again for these type of funding. So why I'm emphasizing this is like, it's like that the feedback or the loop has to get always closed. Whatever fundamental research we do, it has to be translated into applied research. It has to be translated into commercial product. I'm not saying every time it will happen. There can be some exceptions there, but we have to strive for that one. Then only, this loop will continue. This is one thing which I want to always, I used to talk about this one, so that, you can always think of, even if you are academician and all, you can think of how to associate with some of the industries who can really convert into that. I have been doing this for many of the IITs and other people like that. Now let us get on to the subject, the innovation and social entrepreneurship. I will explain first what is innovation. You know this one, but still I have a different what is that called, explanation or definition for that. Normally, innovation, this is a process of translating an idea or invention into a product or service. It can be a service also. So let us. So that is the process. But what I used to emphasize is like I call it as an innovation only when this happens, that process of translating an idea or invention to a product or service for which customers will pay. What it means is like it is not like I am good in some nanoscience or nanophotonics or anything, and I myself will think like I will come up with a product of my own, expecting or assuming that there will be some customer there. So all those things are normal because we have something called a comfort zone. If I am doing my MTech or PhD, then I will get a comfort zone in that area. I know many things there. So I will try to put a lot of things into that one without looking externally. I'm not saying like you are to deviate from the subject or your area, but you have to look around what customers wants. That is very important, more important than your comfort zone. So this is very important. You have to please keep in mind. Why I'm saying this is like, I will come to that after a slide. So on a lighter side, because this evening people will not be listening to the talk. So this is one of the lightest slide. Normally, when you want to break scan, you go to a doctor, you put the plaster and all those things. So the younger people used to use that for drawing all those heart, arrow, and things like that we enjoy. Okay, but once you go with this plaster outside, everyone you meet, you have to tell what has happened because they will ask, especially in India, what happened. So, they will always ask. Okay, so I was thinking, like, why don't we come up with a sling type of thing? On the sling itself, you print the root cause. Like the first one I am showing, like a dog bite. The second one I fell from, the stairs. The third one maybe during the match or the games and things. Fourth one, you can reserve it for some family problem, whatever you want to do not want to disclose. So even though it was on a lighter side, think of the energy saved by doing this one. After this, nobody will ask what happened because it is self-explanatory. So on a lighter side, but still it makes a lot of value. Now, I was telling like, you have to look at what customer wants, or what customer means whoever wants to use it. That is has to be given more important. I will give an example. India, if you take India, there are, I think, around 57,000 startups or so now. All are well, supported, funded. Uh, Especially on hardware side, I am mostly on the hardware side. Even though on software side, there are a lot of apps and things like that, people are making some money. But hardware side, very few are coming up with a commercial product which they are selling and making money. And many were failing also. So there was a post-mortem done on failed startups. And we found out that the major reason for failure is, you can see 42% is like there is no market need for the product which you have come up with. That's why I'm saying, like, you have to always, there are cumulative reasons, ran out of cash, not the right team, lot many things. I'm not getting into all these things. So we have to learn from others. Of course, from the failed, whatever reasons they have come up with, after a lot of studies they have come up with. So we have to be very, very careful on these things. Okay. Now, innovation and social entrepreneurship. Now, you may ask, what is social entrepreneurship? This is also very interesting because we all work with entrepreneurship there. And social entrepreneurship is my explanation is for profit business model that strives to make a positive impact on social issues or the environment. This is very important. People will normally think like social activities are normally, non-profit, so that why to work on, because we have to also make a living, right? It's not like always social work, but how to live ourselves. So I always go for profit. For profit is not a crime. Okay, you can always think of making some profit for your living. And social entrepreneurship here is you are working on some ideas so that it will impact on social issues or the environment. This is very important. So this is one area where I have been working on the recent times. Now you may ask me, okay, those who are students, and how will I get good idea? This is one of the things. Nobody can tell you that this is a good idea, but still you may be always thinking, how will I get a good idea? So I have a few facts here, mainly for social impact. If you look at only India, today I will focus only on India, there are some facts like 680 million Indians cannot meet their essential needs. Three-fourths of the potential impact will come from jobs and productivity growth. 115 million additional non-farm jobs are needed. 50% of social spending is needed for healthcare, water, and sanitation, which is 20% now. So, like that, I'm not getting into all these details. So, there are a lot of requirements in based on the facts, okay, in India itself. So, how these can be converted into the ideas is like, for example, poverty remains India's number one enemy, but innovation has the potential to create positive change at scale. So innovation is the way forward here. So based on the earlier slide, we tried to come up with what can we convert those to challenges. So one challenge is 21% of the population lives on less than $2 per day. So is there any way you can help them? You can come up with probably the agriculture. For example, let us take agriculture. Can you come up with some machines which will improve the efficiency or the crop? So like that. Then 58% of the population dependent on agriculture. 15% is undernourished. So can you do something for that? These are all under social entrepreneurship. See, one more thing I have to tell, compared to normal entrepreneurship, where there will be a lot of angel investors who are ready to put in money. But in social entrepreneurship, the benefit is not only directly on return on investment as cash, but you also do some service to the society. So there are a few organizations like the Social Alpha, if you look at, and a lot of Tata Trust, and not many people are helping you even in these areas. So not to bother on those things, like whether I'll be able to get investment for my product development and all. It is already there. Lot many people are doing that one. So this also you have to be very, very careful, and people give more value to these type of startups. So you can see in India also a lot many people are working on the ideas which are very much relevant to social impact. So challenges and opportunities, like 7% annual growth in GDP. This is before COVID. So that is a very good number. 64% population in working age. So whatever product we bring in, if we are able to do it for the working age, then that would be very good. We can reach 64%. Then another thing is opportunities, 800 million unique mobile users most of the people start using mobile phones now. So whatever product you come up with, if you can link to the mobile phone, so that you can save a lot of advantages are there in using that one. Then household banks, then 90 billion annual infrastructure spend, and all those things are opportunities. So you have to really come up with the areas where you are comfortable with. So from the first and second slide, I am coming to little bit more specific. For example, agriculture and rural development, based on the prior two slides. Lack of mechanized tools for small and marginal farmers. So I can tell a lot of example where I am working now on these areas. We are coming up with some equipment which will help. For example, I will explain that later. For example, the fruit farms are there. The fruit farms, what is done is like you take the fruits and send it somewhere, then make the pulp and juice and all those things. Okay, so by that time, there are a lot of losses happening there. So some of the people wanted a fruit pulp, what is it, the packing system very near to their the farm. So can you think of a low-cost portable packing machine which can be used there? Which will take very less current and things like that. So those are some of the ideas which you can also think of in agriculture. Then farm productivity, manual drudgery, post-harvest losses, poor market linking, all those things you can really think of. Then on water and environment, a lot of work is going on. We are also associated with Toilet Coalition Board, where we are working very close with them. So here the groundwater depletion, then widespread pollution of both surface and groundwater, significant air pollution. In all these areas, we started working on this one. Then living conditions and all, whether you can improve. Financial, I will just leave. Then women's safety, high levels of violence, so some alert systems, low participation of women in formal economy. So are you able to bring in such things? Then waste management, sanitation, that is another one. Like we are now working with some of the startups who are working on dissolvable sanitary pads. Then another startup is working on collecting the pads and then convert them into some usable material. So all those things are opportunities here. Based on which area you want to work, you can work. In health, lot of opportunities are there. Health is one of my favorite area where we are coming up with. We are working with many equipments, including MRI and all. So persistence of TB. That is one thing. If you see TB, when detected, they give the tablets and all. So whether people are taking proper, can you come up with a device so that you can also monitor from public the PHC, primary health center, whether these people are really taking the tablet. So all those devices are all beyond your imagination. You can come up with anything. Education, lot of startups are there, not only for the normal people, but for the impaired, the blind people, deaf and dumb people. Then clean energy, that is another one, like electric vehicle and solar energy and all those things. Physical disability also, a lot many work we can do. Like for example, handicapped people. Can you come up with I will show that example which we have done. We have come up with the crutch which is very stable. Even you can use it on the sand and things like that. Very stable with the life is extended like anything. So all those things in everything, exoskeletons. You can see lot many startups in Kerala also are doing very nice activities on those things. Okay, so I will advise you one thing. Like when you are starting an idea or entrepreneurship with your idea, I will always ask you to go through a checklist. This is a self checklist you yourself can do. I will explain that and then I will go ahead. First one is originality. You are not copying from somewhere. Means like you read some paper. So I am also doing something. A spoon for Parkinson people. So everybody will do the same thing. So you have to have, because you are going to start your career. If you are very serious on that. So originality doesn't mean that which is non-existent, which is not there. I am coming up with some innovation. That is not required. Originality can be incremental innovation. For example, a mobile phone is there. So you need not invent the mobile phone. So can you come up with a mechanism, for example, an attachment for the mobile phone so that you can use that to detect maybe glaucoma, or you can detect cancer, whatever it is. So that is what you have now. You are not going to make the mobile phone, but you are going to make an incremental innovation. So that is what you have to see. So it has to be, you have to be very, very, very careful on that one. You have to have some innovation. You can stand on someone's shoulder and then look ahead also. That is what the second one, prior art status. What people have done till now. You have to first understand what people have done till now on the idea which you are thinking. So you can do a prior art search using, even Kerala Science, the State Council for Science and Technology can help at all. So you have to know what people have done, then you think what else you can do. So there is not much time. I would have shown some of the examples on that. Patentability, is it patentable? That's what you have to see. Then you have to also know market analysis, competitive products, who are all there. So it is like you have to first open your eyes and see what is around in my area. So you have to have a very clear idea. So people may ask, like, sir, I'm getting a lot of funding, so why to bother about that? See, funding agencies, there will be some people to assess it. It is not like everybody knows everything. In your area, they may not be knowing much. But you, even though you are getting funding, you are fooling yourself. So that has to be kept in mind. So it is your career, so you have to be very, very careful. So once you know what is happening around, then you can come up with something very nice. Development cost and time, very important. Don't take development cost, which is very much higher than the competitive products or similar products, and time, the development time will take maybe 5 years, 6 years, then you will die actually, because you don't have enough revenue for yourself to get sustained. So that is very important. You have to be very, very careful on those things. Product cost. This is actually one misconception what we have normally. Normally what is done is like, I will buy some system from US, for example. I will bring it here, open it up, and take out all the parts. I will put the part cost of each one, add. You will see that it is almost half of the price of what you have bought from US. Okay. So then you will think like, okay, why don't I do the same thing here? Then I can sell it maybe 10%, 20% profit. So you have to be very clear on what is meant by product cost. I will explain that at a later slide. It is not only just a bill of material cost. There are many more factors for that. So you can see, for example, in India, what we have the industry for mechanical things. We have industry for some other thing, but we don't have really foundry for electronic components, mainly ICs and all. We are getting from other places like Singapore. Now only government has already initiated. I think a lot of work is going on. That is which is very much required now. For Atmanirbhar Bharat, that is required. So that is required. So you have to buy all those things from outside and then assemble it. So what is the advantage of India? Is it labor charges less than other places? It's not like that. There are, even though China is little more now compared to India, but there are other places like Philippines and other places where labor is less. So what is the advantage? What you can do, or you can, if you want to stand in the global market, is like innovation, engineering. So all those things. I call it as disruptive innovation. Disruptive innovation is, for example, don't think in the normal way, then the product cost will come to the same thing. You have to think, can I come up with an alternative way of realizing the same product? That is disruptive innovation. So in that way, you will be able to bring down the product cost. So that is the one thing which I want to emphasize on to you. Repeatability. That is one thing very interesting. Repeatability is like, you are able to make one product. You are not going to make many volumes. So your design has to be done in such a way that even if an ITI guy is doing in manufacturing, it should work at one stretch. It is not like you have to sit on every product and then make it work. So your design has to be done in that way. A lot of examples I have, like for example, for the electronics people, for the resistance. We learned that tolerance ring, relevance of tolerance ring, the color of that one and all, during the now maybe +2 and all, or even 8th standard, earlier our days in initial colleges and all. So that is a tolerance. That, when you are building a product, that makes a lot of things. There is a tolerance analysis which you have to make. Similarly, in mechanical also, tolerance analysis you have to do. Otherwise, what happens is, like, when you assemble everything, the product will not be repeatably working fine. So that is one thing which you have to be very, very careful. Then manufacturability, I explained. Whatever you make, for example, a mechanical people, you make a SolidWorks box, which you give to a manufacturing unit, he will not be able to make like that. There is something called tolerances there also. There are some processes, so there are some limitations there. So your design has to be designed for manufacturability. So that is very important. Then sustainability. Okay, so if you are academicians and all, and you don't have time to really come up with a company and all those things. So there are other ways you can sell idea, not taking it further. So there are some ways to do that one. So prepare a professional presentation and you give this presentation to some of the potentially interested parties. Then you have to prepare target parties, and then you have to, the major hurdle is how to value your idea. Okay, so if you have a proof of concept to prove, that will be add a lot of value, but you can take help of some of the mentors, some of the experts who will be able to come up with what can you ask for your idea. So the idea, people investors or the other people who are going to take over the technology can give lump sum money, or they can also tell, like, okay, every product sold, I will give maybe 2% of the product cost as a royalty. So this is also possible. So you have to be very careful on that. Stages in development, if you are interested, I think you might already knowing the idea, that is by innovator. Once idea is there, the first stage is that has to be proven to others, proof of concept. That has to be done some sort of in R&D lab or incubation center, where you can use the available equipments, power supply, CRO, whatever, spectrum analysis and all. But the idea is to prove that. So it is not in form and fit of the final product. Once that is proven, then you go for the final design. The final design may include lot many things, electronics, mechanical, industrial, and all those things. Once you do that, you transfer to manufacturing, then the sales and marketing happens. So here, the first two things, idea and proof of concept, I always suggest you work with, you be in an incubation center instead of yourself setting up a company, because you have to worry on the payment of electricity bill, payment of the networking bill, then pollution control, panchayat, payments, all those things. Once you get involved, you will not have time to think on your product. So all those things will be taken care by the incubation center guys, so that you can just go there, sit and use your full time on that. So that is one. Then some of the proof of concept, design and manufacturing, you need investor unless you are very, very rich. So this you can get in various ways, angel investors and government funding. Government is funding like anything. Now, if you have an idea, I vouch there is no depth of funding. Then the sales and marketing company you have to make. So always I used to tell, like, when you are academicians or idea stage, you are sort of worshipping, Saraswati, and once you are into industry, startup, entrepreneurship, I think you have to start worshipping on Lakshmi side. So you have to think of economics also, not only the scientific parts. Step-by-step process, if you want to know, this is not a fixed process, but I will just explain for you to understand. So your idea is a very good idea. You did a self-check. You can discuss with friends and trustworthy people, because if you share idea, people can take that idea and go also. So you have to be very, very, very careful on that. Once you have idea, you should file a provisional patent where the validity is maybe 1 year. Okay. You can also register a company, even though you are not doing much on with the company, but when some of the funding agency will ask for how long you have been a company. So it is better to register a company, identify and occupy in incubation centers. I explained to you, have a business model, get government funding and angel funding. Lot many Kerala State Science and Technology Council, then BIRAC funding, DBT funding. Lot many fundings are there. METI funding. Lot many people are funding that one. Then Nidhi, Prayas, Nidhi Ayog, lot many funding opportunities are there. So your idea is very good. I am very sure you will get funding. It can start from a few thousands, lakhs, and crores. Then you demonstrate a proof of concept. Then, and by that time, you are very clear on what you want to do. You can file a patent. Please be very careful when we are enthusiastic. We publicize. So don't publish anything till that time, because once you publish, the idea becomes public. So you cannot file a patent on that. So you be very careful. Go to market strategy, venture and other fundings, move out of incubation and set up your own facility, form the complete team, including sales, then develop the final product and the business starts. As I said, I have shown in a serial order, but some of them are parallel. This is one thing which I have to explain, then I will get on to a few examples and stop it. This is the product development life cycle, which is not really followed by startups and entrepreneurship, because entrepreneurs are always in a hurry to come up with the product. So we normally follow ad hoc methods, a chalta hai type of methods, but that will not reach first time right. Sometimes you think like, okay, certification and all, I will see when my product is ready. Then, that is not the right approach. I will explain that in this slide. So you have a concept, the proof of concept I explained, you made it, then you are going for design. Design is also very important. Like, you have many expertise required here. For example, industrial design, whatever product you are doing, you are developing, it should look good also. Okay. It's not like you will put in a box and show to some investors. That should also look good. Look good means it's not only aesthetic, but also ergonomic. These two factors are there. Where to keep which button, so that, user interface is very clear. A lot many things we can go on talk on that one. Once design is done, the first one is proto build. I call it as an alpha proto build, the first proto. You can use 3D printing and all those things. Then make maybe 5 number, 10 number, depending on the type of product, give to some of the potential users. They will give a feedback, implement those things, iterate it, come up with a beta proto. That's all. Alpha and beta. You should stop there, not gamma proto and things like that. So you have to do a lot of homework on that one. So once the proto is developed, then you are going for pilot build. Pilot build should happen in the final manufacturing facility. If you are not going to manufacture 5,000, 10,000, 1 million, you will identify an EMS, electronics manufacturing service provider, who will do the manufacturing. So you transfer everything to them and they will make the product. That is only called pilot build. The alpha, beta, proto, you can also call it as an MVP, minimum viable product also. Okay. Then you go to pilot build. That's the final thing. Then you do the compliance testing, because compliance testing is like you are making something, you are going to come out in the market. So socially, you have to make sure that you are not radiating unnecessary waves, RF waves, or things which will affect others. Even if some other unwanted things are radiations are there, that will not affect your product and it should work. So all these EMI, EMC compatibility things you have to do. So that is what compliance testing. Compliance testing, I have to admit that it is not a very straightforward thing. What we do is like we do all those things in the design itself, in the first design itself. Okay. Then reliability testing, that is another interesting thing. When you are coming up with the product, you have to tell what is the warranty for this one. You cannot go to a Jolsier and ask him how many years I can get. It's not in that way. You have to do some highly accelerated life test. That means your product you subject to some highly accelerated environment, some difficult environment. Then you take that data. From that data, you can derive what can be the life of your product. For example, mobile phone. I'm developing a new mobile phone. You put it in a pressure cooker, burn it for 2 hours. Pressure cooker, I told, because 85 degrees Celsius, 85% relative humidity. Burn it for 2 hours, take it out and switch on and see whether it still works. And also during that, when that it goes for testing for 2 hours, you can take reading, and also you can see what happened. From this data you can find out what can be the life of the product which you are going to come up with, because it's a new product you are going to design. You have not used for 5 years, so how can you tell that it can be used for 5 years? That is how a commercial product comes out. Okay. I have a case study, but I'm not going to go through these, but I will just glance through. For example, this is an ultrasound machine. Okay. If you are thinking like, oh, it looks very bulky, can I come up with a very sleek ultrasound machine? So this is what we have done some time back. So I will take you through the every stage here. The proof of concept you can see it is using a normal keyboard and available thing, and also I'm showing only the console. Okay, I'm not showing all other things because of the IP issues there. I don't want to disclose all the things here. So this is how the proof of concept. That means you assemble everything on a tabletop, and you are going to prove that using this technology I can come up with an this ultrasound machine. Once that is done, I move on to design, which involves all these things. So you can see the design, how complex it becomes. Only the console I'm showing, I'm not showing the other things. So here, I just wanted to tell, there, if you look at on the right hand side, the pink color, whatever that color, that is actually a rubber sheet which we put over the PCB. Why? Because you have to look at what environment this ultrasound machine will be used. People will be using some gel. Doctor will be putting some gel before doing the ultrasound. So this gel can fall on the keyboard. Then what happens? The console should not go back. So even if something falls, it is made, the rubber sheet is put in such a way that is will not go on to the electronic board, but this will get drained to some other place. So these type of thing you will never think when you are coming up with a new product. So unless you think the reliability and all those things. So another example I will show here. This red colored portion is the place where doctor or operator will be using most of the time with his palm. So a lot of pressure will be given at that point. So if you are mechanically, when you are designing, when a pressure is given, stress is given, it should not bend, and then it will spoil other electronic circuit. And so you have to make that enclosure in such a way that there is no deflection happening during the operation. So what is the way you increase the thickness of the material? So that is not the right engineering way. That's what I was telling. So instead of, when you are increasing the thickness, you have to put a lot of cost will go up and material, a lot of material. So instead of that, you can think of during the design some strips or ribs, we call it as a ribs, at proper places, and with a particular design, if you put only ribs, that will also give equal strength as the increasing the material or the thickness. So those things you have to really look at. Then proto build, you can see a 3D printed thing, the console I am showing. So proto we reached. Then I am going for pilot build. I told you pilot build has to happen. This is the final product. There is nothing much on that one. So you can see it is being made in manufacturing unit. All the color, everything is finalized. Now the final product comes out, very sleek compared to the earlier one. Then the compliance testing, you can see so many tests you have to do. You have to, if I focus only on the console, people will be cleaning with a lot of solution, and also what happens. So all those tests you have to, the compatibility tests you have to do it. Then reliability testing, for example, some of the switches you have to make sure that the switch will work for 10 million times. So we came up with a mechanism so that if we go on pressing that switch 1 million, 10 million times, when the switch goes bad, it will give a count, how many times it has been pressed and what is the life. So like that, you have to plan all this. So why I'm showing all these things is like when you are very serious on product development, you have to think of all this. You have to take care of it. So this is a design to manufacturing transfer process. So you are a designer. When you are transferring this to the manufacturing unit, in manufacturing unit, who is going to do that? An ITI guy. He will do whatever is told to do. So everything you have to transfer from you to manufacturing unit through documents only. It is not that you will go and sit with the manufacturing people and tell what has to be done, where to put, and all those things. Nobody is going to tell. Only some clarification you have to do. So these are all some standard processes already available. So you have to follow this so that you can transfer your ideas to the manufacturing. So this is one example I'm just showing here. I don't want to explain on lot on that. So the product cost, I was telling, the product cost consists of bill of material cost. That is, whatever is there, you put the cost of everything inside. As I said, inward freight cost. Some of the components you have to get from outside, so you have to pay customs duty. Conversion cost, that is, which includes solder, other consumables and all being used to assemble that. Assembly and testing cost, somebody else will be doing, so you have to pay them. Packing and brochure cost, R&D, development, tool cost, amortization, all those factors you have to add on that. So your selling cost will be product cost, which is, you have seen so many factors, plus profit, plus distributor margin. If you are not going to sell it directly, you have to identify a distributor who will sell that. So that's what you have to do. I will these are some of the products which we have come up with, healthcare, then water filtering, it's a social impact. The first one is like the newborns, when they have these jaundice, they are taken to NICU and they put it. So we thought like, if these jaundice treatment can be done in a local area when the infant is very near to mother, so we have to come up with a blanket. So the infant can be put on the blanket and they can wrap it with the normal cloth, towel and all. So this will work for the treating the jaundice. The second one is a water purification system, which we have come up with. The left hand side, what you are seeing is this is very popular. We have come up with a solid state portable vaccine carrier equipment. So inside, the temperature is maintained from 4 degrees to 7 degrees Celsius, battery operated. This will be there for more than 72 hours. So you can carry this for rural people so that the vaccine can be carried. This is my last slide. You may ask, what are the other social entrepreneurship or products you are working on? I will just mention a few of them. Braille printer, we are developing a Braille printer, which is very much useful for the blind people. Wearable for deaf and dumb. For deaf and dumb, they cannot hear if you are calling their name. So we have come up with a wearable like a watch, wristwatch. So if you call them Suresh, then what happens is like this wearable device will decode that and give a vibration and also show it on the screen. Suresh, somebody is calling Suresh. So that way. Infant temperature monitoring system. That is another one where in rural areas and all, they don't know what is the temperature of the infants, and also we have come up with a very small wearable which can be just tied on the infant. Paddy grain analyzer. This is for agriculture. See, when the paddy grains are made, people used to do sort of asking to understand what is the grade of the paddy. So that is a tedious process. And we have come up with an optical based system so that you just put the paddy grains and it will tell what is the grade of this one. Radioisotope vial filling equipment, I will just skip it. That's a small portable equipment which is used for isotope filling. Hyperspectral fruit inspection. If you want to see the fruits, how it is, the quality, we came up with a small conveyor belt where the fruits are all just rotated 360 degrees. At that time, a camera is put and then it monitors. Hyperspectral, that fruit pulp filling, I told you we have come up with a very portable one which can be used to fill the fruit pulp. Breath-based cancer detection, that is still going on. It's a very R&D based one, but we are doing the technology and the engineering part of that. Intelligent shoes. So there are some shoes where, the shoes itself, when you walk, it can give a lot of information. Bio air cleaning system, like air, what is it called? Cleaning, like in the hospitals and all, we have come up with the small tower systems which can be used for that. Vaccine carrier, I told, water saving. Water saving is like whenever the water from washing machine comes out, we just throw it, put it in the drain. So now there are some other some activities going on, whether that water can be taken and filtered and used in toilet, bathroom and all, whether that is possible. Soft robotics, another one. AI-based urine measurement is another. Wound healing, etc., etc. I can go on talking on all these things for a few hours on that. So I will close because it is 4:49 now. That is 49 minutes. The summary is like prototype development completion is only 30% of the whole job. Why I'm saying that is many of the startups and entrepreneurs, they have some prototype, they say that they have almost done it. But you can see what is the product development life cycle, what are the things you have to carry. Now, before ending, there are many startups who have completed their product development and then they failed in the compliance testing. They came back to us. So it is very difficult to change the design when everything is done, but it fails in the compliance testing. So those are all difficult times. Sometimes they have come up with a product, when they install at the real site, it failed. So they have not really taken care of ESG issues and all those things. So these are designed for manufacturability, regulatory compliances, etc. shall not be an afterthought. That means you should never think like, I will do that at the last. So please do some work on that. It may take one more week, but put all those things into your design. Take help of hands-on mentors. It helps. A lot of people who have done this type of thing, that helps a lot. Excellent opportunity for startups to make social impact. Lot many fundings, lot many support, lot many programs are there. So those who want to really gets into social relevant product, then this is the right opportunity for that. Thank you very much for listening to me. Any questions or anything, I will be glad to. Yeah, I think a lot of chat box is full. Oh, it is repeated? I don't know. Okay, this is. Dr. Sherin, any questions are there? Can you just?
No, sir. No questions in the chat box. Only.
Okay. I think this is only the okay caption.
So, can we wind up, sir?
Yeah, sure.
Dear participants, we have listened to a very interesting talk on innovation and social entrepreneurship aspects. So we may have heard many talks on entrepreneurship, but today Dr. Suresh has taken us through a very different aspect of entrepreneurship, that is social entrepreneurship. encouraging us to contribute back to the society as well. So thank you, sir. Thank you for being with us. And Dr. Suresh has also taken us through different funding opportunities and aspects regarding how to find avenues and markets for social entrepreneurship so as to make world a better place for us to live on, us and others to live on. So thank you, sir. And also thank you for taking us into different product journeys and giving our participants an insight into where to focus on what when you start a startup. So thank you, sir, for taking us through this wonderful journey. Thank you for joining us on our invitation. So we hope to associate you in future endeavors as well. Thank you, sir. Thank you. Thank you all dear participants for joining us. So this is the last webinar. This was the last webinar of the webinar series organized as part of NTD 2022 celebrations. So hoping that you also joining in our future programs. Thank you all. Thank you. Thank you for joining.
Thank you.